So there's a special type of object that we haven't talked too much about yet, and these are missing values. Missing values in R are denoted by either NA or NaN, which we talked about before. NaN is used for undefined mathematical operations, and Na is pretty much used for everything else. And so there's a function in R called is.na, which is used to test objects to see if they are NA, to see if there are missing values in that object. There's another function called is.nan, which is used to test for NaNs. So NA values can have a class too. So you can have missing integer values, or you can have missing character values, or missing numeric values, etc. And so even though it looks like it's all NAs, the NAs can have different classes potentially. And then an NaN value is considered to be also NA. So for example, an NaN value, a NaN value is missing. Is considered to be missing. So, but the reverse is not true. So an NA value is not necessarily a NaN value. I've got a few different types of missing values listed here. So here I created a vector x, which is 1, 2, NA, 10, and 3. So now this is a numeric vector, and the NA value in here is going to be a numeric missing value. So when I call is.na on x, what it returns is a logical vector. And the logical vector indicates whether each element of the vector x is missing or not. And so there's only one missing element in this vector, and so that's the third element. So you can see that the logical vector that's returned, the first two are false, the third is true, and the fourth and the fifth are false. So the element that's true indicates where the missing value is. If I call is.nan on this vector, you'll see that the vector that's returned is all false, because there aren't any NaN values, there aren't any NaN values in this vector, so everything's false. Of course, if I create a vector that has a NaN value in it and an NA value in it, you'll see that is.na returns true for both of them, but is.nan only returns true for the value that's actually NaN.